Good afternoon, everyone. Hope everyone's doing well today. Just a reminder to please mute your phone. And if at any time you have any questions, just unmute your phone, to press *6, and we'll be glad to answer any questions that you have during that time. So feel free to jump in so that we are not just talking to the telephone. So we'd love to have your input. My name is Patty, and I'm here to share today with you some exciting hands-on science products, new products that we've created called Ward's Essentials. And along with me is my science sidekick person. She's my better half in the science world. So together we make a really good team. So we're here, and if you have any questions, please feel free to ask.
And my name's Michelle.
Didn't I say that? No. That's Michelle. And sometimes we get a little Ethel and Lucy, so forgive us. So today we're here to talk to you about some Ward's Essentials kits that we have created. They're brand new kits that are low-cost kits, and we're going to demonstrate some for you today and share some of those activities with you. And we're going to share some additional products, and we're going to have a wrap-up for you. So as we said, if you have any questions during the presentation, please feel free to ask us then. So our Ward's Essentials are, you can go to the next slide, please. Thank you. So our Ward's Essentials are low-cost kits that we created. They cost between $50 and $75 for the most part on the price point for you. They are designed for 15 student groups, and they include teacher instructions and a student guide. The teacher's instructions contain enough information to complete the activity, so they're more geared to our experienced teachers. Anyone can use them, but the content that's included is enough to get you through the activity. So if you're using this as a supplemental activity to whatever you're doing, this is the perfect kit for that. The student guides are 2 to 3 pages long. They can be reproducible, and they only contain the procedure and any data tables for the students. So you don't have a whole lot of pages to reproduce for the students to use. They focus on one activity. They have follow-up activities and questions, and most have some extension activities as well. We have topics across all the disciplines, and we have a lot that focus heavily on STEM with math connections and engineering and design. So they're really nice kits. They're exciting and new, so we hope that you like them as well as we do. You can find them all on our website, and they'll be in our new catalog that's coming out, so be sure to look for those. So we're going to share a couple of activities with you today. And the first one is one of our chemistry activities, and it's an exothermic reaction. And in this lab, students will monitor and graph the temperature changes in an exothermic reaction and create a heat pack, which also utilizes that exothermic reaction. So this is a great lab to use in the beginning of the year to get students familiar with safety procedures and safety precautions, and following directions and good listening. It's a great beginning chemistry activity. So in this reaction, it is exothermic because more energy is released during the activity. So the procedure is pretty simple. And what we're going to do is start off with 50 mils of water, and we're going to put it into our plastic cup, and we're going to place our thermometer in there. We're going to put on our safety goggles.
Safety first.
Safety first, always important. And we're going to take the temperature of the water, take a reading, and the students will record that in the data table that we'll show you in a little bit. Actually, you can go to the next slide, please. There we go. So once we have our water in there, we are going, and the students would measure this out, well, in the sake of time, we pre-measured our chemicals. So we are going to take 5 grams of calcium chloride, and we're going to mix it into the distilled water, and we're going to take our temperature reading every 15 seconds. I'm going to scoot over to our close-up camera. Oops, and let me see. There we go. Okay, so we're going to add in our calcium chloride.
Good thing those chemicals are safe.
They are very safe chemicals. And then with a stopwatch or phones, the students will take readings, and they can work in pairs or in small groups. And they're going to take their temperature reading and record it on a data table that is similar to what you see on the PowerPoint. And they're going to record the time and the temperature every 15 seconds for 2 minutes. So let's see if we can see our temperature.
PowerPoint.
If you can't see the PowerPoint, you can email Science Help, and they will get you hooked up to that.
I have one question. Does
Okay.
it have to be distilled water, or can they use tap water?
They can, tap water should work. This is actually what this is as well. So I can see, you can't see, but the temperature is increasing slightly on here. So as we're as it stays longer, we'll see more of a reaction. So the increase in the temperature as the reactants are mixed shows that this is a exothermic reaction because more energy is given off, and we can see that through the temperature reading that increases. So as the students complete the data table, they will be able to see that the temperature will increase over time. So that's a nice, easy activity. Any questions on this one? Okay. Then another nice activity that comes into this kit is the students will make a heat pack. And everything comes bagged in a nice little bag, and there are enough for 15 student groups, so that makes it really nice and convenient. So we're going to take a bag that contains iron powder, sodium chloride, calcium chloride, and vermiculite. And we're going to simply add 10 milliliters of water, seal up our bag, squeeze it and shake it.
Good for those fidgety kids.
Yeah, who needs a fidget spinner?
Could you please just mute the phone *6, please?
Just someone's asking if we can move the boxes or anything.
Oh, sure. So as we mix this, we can feel that the contents are getting warmer. So then again, the students would record on the table. They could record the the temperature and the time. You can put the thermometer into the bag as well to see the reactions that can go on there as well.
That gives you a quantitative result, right?
Yes, it does.
Ah,
And so this kit also contains follow-up questions for the students so you can check their understanding. So it's a great way to, like I said, start off the school year, talk about lab safety, following simple directions and procedures. So that's a nice little activity, just a demonstration of one of our chemistry kits. We have about 9 chemistry kits that are very similar to this. They contain enough materials for 15 student groups and are very reasonably priced.
so those are 9 essential chemistry kits,
Right,
right?
yes.
Okay.
And our essentials kits only contain the materials that are really necessary for the activity that are non-labware. So in this kit, the chemical comes in The cups come in, the packet of chemicals comes in, the thermometer's not included, or the cylinders. So those are things that you most likely have in your classroom, and if not, you can always buy them on our website. But we did that to keep the costs down for you so that you had some great hands-on activities and not a lot of extra things that you probably already have in your classroom. Now we're going to move on to one of our physical science kits. And this is our Catapult kit. Now, our physical science kits that we have some of them that are a collection that come with one apparatus in it. So you don't have enough for 15 student groups, but they are low cost and they're economical enough to be able to buy multiples to share in the classroom. So you can set the students up in groups. We have 7 different of these type of apparatuses, so you could buy 7 different ones and put them up in the station. The kids could work in stations and rotate through and to do all of the lessons. So this is a fun one. It is a catapult, and it allows the students to play with the physics of catapults within some fun and easy activities. The students can experiment with different arrangements until they find the optimal configuration to launch their ping pong ball. So this type of catapult is a type 2 or a class 2 lever because the load is between the force and the fulcrum, and the rubber band pulls the lever arm, and so that helps. The force is proportional to the stretch of the length of the stretch of the rubber band. So this kit is pretty fun, and the kids can do it pretty well on their own. You can set this up yourself ahead of time, or the students can set it up. There are instructions in both the student guide and the teacher guide. And so one of the activities we have them doing is to set a target to see how far away you can reach. The table tennis ball can reach that target, and you can stack obstacles in front of your target. And what the students will do is move around. The force dowel comes out very easily, and it can move to a different position. Same thing with the stop, where the arm, where the arm will stop, and with the fulcrum. So they can have different testings that they can do to determine where they get the optimal range out of the catapult. If you can go to the next slide so they can see the PowerPoint or the...
I'm sorry, did you say there was instructions included with this kit?
Yes, there are instructions included with all of the kits. There are teacher guides and a student guide, and the student guide contains the procedure and any data tables that they need to record information on.
Thank you.
Thank you. So you can see on the data table, they have the students moving all of the fulcrums and the stop and the force dowels to different positions to see where the best performance comes out of there. So we won't launch our catapult at our cameramen here. But this kit also contains follow-up questions and additional inquiry questions. There is also an extension activity that incorporates math, as they use a protractor to measure the angle of trajectory and then determine the initial velocity of the ball. And there is a formula included, so you don't have to struggle with that one if you are not the math teacher. So this is another great essentials that we have, and they're nice, sturdy wooden apparatuses that you'll get a lot of use out of.
You have a couple questions.
Okay.
Are the standards aligned?
Yes, the standards are aligned. They are aligned to the new NGSS standards, and but they will align to state-specific standards. Part of what Michelle and I do is we help to align kits to the standards. So we get requests all the time from teachers who are looking for an activity to teach a particular standard. So if you run across that problem, if you send science help an email or you email one of us, and information will be on the end of the PowerPoint, we'll be glad to help you identify which standards these specific kits will cover. Okay? Okay, we're going to move on to one of our other kits that is called Clearing the Water. It's a great engineering activity for the students to do. Very simple to set up, a lot of things to track and enter information on data tables, and opportunities to test and refine their what they find. So the first thing we're going to do, and you can do this before class, is to poke 6 holes in the bottom of the larger cup. We include a screwdriver to help you do that, to make it easy. And then you'll want the students to cover the holes with the tape so that when they put their items in, they won't fall out. So the first thing we're going to do, and you're going to want the students to track how much of each material they're going to put into their filtration system so that they can determine which one worked the best. So we have our supplies out, and we can just go ahead and let the students create what they think would make a good water filtration system. We have gloves that are included. We have activated charcoal. We have some clay soil, sand, pebbles, and coffee filters. We have foil pans and cotton balls. So there's many things for the students to choose from that they would want to make their filtration system with. So, and for the sake of time, we're not measuring right now, but you would have the students measure how much. They could measure by the spoonful. You can have them measure using a scale or a balance. To determine that, you can bring some math into the activity. So it's a good way to incorporate more pieces into the lesson.
Also, if you see the top of the screen, there's a place that they can actually draw their configuration of how they put it, and then they can add how much of each onto that.
Now you could have the students test the components separately to see if that worked as a filtration system, and they could share the information that they collected. You can have them do that together as a class, or you can, they're going to share the information that they've collected, but if you want to save on some materials and not have them create some crazy contraptions each time, they could share the information that they gathered from testing.
Maybe some pebbles.
Okay.
Okay,
Are you ready?
I'm ready.
Okay. So included in the kit are nice measuring cups, which will be very helpful and make it easier for the students to collect information. So what they're going to do is take the empty measuring cup, put their filtration system in after we've removed the tape.
I just thought of that too.
And then the first thing we're going to do to prime our system is we're going to pour in about 75 mils of water, clear water, just to prime it, to get out empty spaces. And so this is a good way for the students to see now what they've put in and what they're taking out. You have nothing happening. So I've had water come through my system. It's not very clean.
Oh, there is a little water. It's not a lot, but it's a little. So that might be a question that they can figure out. Why did it go through that so much faster than this?
So once it stops dripping, they would record the amount of water that was collected in their cup. And then what we're going to do is now test some polluted water. So we've added some red food coloring, and now we're going to determine, we have to empty out our bottom. Now we're going to determine if our filtration system would filter out the contaminant that is in there, and in this case, it's the red food coloring. So we're going to get rid of what we've collected.
What we could do instead is grab another cup that's a measuring one. Just out of cooking show science special. All right.
Okay, and then we're going to pour in this is about 100 mils of water that has food coloring mixed in. And so what we want to see is clear water come out from our filtration system.
Here it comes. So you could also talk about, if you've got advanced students, porosity and permeability, and introduce some of those vocabulary words to explain why yours is faster than mine.
So what you all also will want to discuss is the rate at which the water is filtering through, and obviously the clearness of it, to see if the filtration system worked and if it was able to filter out. So I have a pretty good amount of water filtering through, but we can still see the red food coloring as the contaminant.
And mine actually looks more clear, but is just slower.
So this would be a great opportunity for the students then to compare the results that they found, go back, revamp, and see what works. So it's a really great engineering activity, and it makes it very lifelike or real-world connection for the students. It's something easy. We use water every day, so this is a great activity that incorporates some earth science and engineering.
Could you use other pollutants if you wanted to?
Certainly.
So if you wanted to just see turbidity to disappear instead of a color, could you do something like that?
Yes. Yes, you could.
Okay.
Okay. So our next kit that we have is a really fun kit, and it's called a bone to fix. And this is a great engineering kit. And in the kit, we have all sorts of tools, and we have some fake bones, and they are styrofoam rods. And what we're going to do is, if we were doing this in the full lab, using weights, you would tie a string and attach some weights and hang the bone over the edge of the table and record how much weight the bone could take before it really got a bend in it. For our sake of time, and if you were scrunched for tough for time in your classroom, you can have the students, they can just do it by feel even. So how much pressure could they apply before the bone would snap? But we don't have weights in the kit because they're pretty expensive. So if you don't have weights in your classroom, we suggest using washers or anything else that you can have enough of for the students to use as a weight to measure. So there's also included in here a chart that they can record how much weight their bone, unbroken bone, will hold.
Sustained.
Thank you.
And actually then they could do the weight by number of washers.
Yes.
Not just weight, but
Right.
Okay.
Yes. So in this kit, the students are going to be a surgeon or a bioengineer,
Biomedical
engineer to fix the bone. So once they've tested the solid bone, we're going to break our bone, and they're just going to snap it in half or twist it or break it however they want to. And then what we're going to do, which is just a way to show them that, if we put our bone back together, it may hold and it may look good, but if we put any weight on that or we try to bend it like we did the other, that it's going to break. So it's a way to show the students that we got to do something to fix this poor, what was his name? That broke his broken bone in our kit. I don't remember what his name is.
Oh, Carlos.
So then what we'll do is use some of the tools that are in here that kind of resemble items that a surgeon may use to help repair the bone. So the students can pick, there's a variety of materials. So the students can pick different things that may work to fix their bone. And what we're going to do after they fix it is measure again to see how much weight their fixed bone will sustain compared to the original bone.
You can talk about internal fixations and external fixations, and I'm sure there's people in the class that have broken their bones and had them fixed. They'll talk about staples, as far as these are actually packaging staples, and staples are used in surgeries a lot. So it'll give them an idea of the purpose of some of the things in real life.
And a great way to expand this activity would be to assign a monetary value to the pieces of material that they're using, and that could be a factor into what they're using to repair the bones. So again, we're going to pull some math in there, make it truly a STEM activity.
Question on how many bones come in the kit? Do they have to work in groups?
There is enough for 15 student groups. So
they come in three long bones that they can cut into thirds, so that it ends up getting, there are 6 long ones. So it actually gives you more than 15 to play with. Make sure I do something a little different than you, right?
Oh, I can't
I'll do inside, not outside. So I'm doing internal fixation while Patty does
I'm going to do
external fixation. They do have to be careful with these because there are some points, but as long as you draw their attention to it.
I'm going to put a purple cast on mine. So, and you can give the students a time limit on this, so it puts a little extra pressure on it. You also want them to keep in mind, if this was truly a real surgery going on, that you would want to be considerate of the pain that they're fixing their bone was going to cause the patient.
So the more things that they do to it, the more that would have to be done to the patient, right?
Right.
Okay,
Okay.
I have mine.
All right. So I'm going to, so I can feel my bone wiggling, and it's not going to fall apart right yet, but I can feel it wiggling.
Mine's wiggling, but it will definitely fall apart before yours will. I think you won this one, Patty.
And so if they're testing with the weights, you obviously will get a more consistent readings, and to see whose bone sustains the fixes better.
Again, that quantitative value, right?
Right.
Great.
So any questions on that one?
One, does everything you're using come with the kit?
Yes. Yes, everything here comes with the kit. We have all sorts of different, we have sticks, popsicle sticks, stir sticks, so different qualities. Skewers, dowels, staples, rubber bands, and foam paper to rub.
And fasteners.
One of the other extension activities on this kit, which is a kind of neat one, is to talk about osteoporosis. And so what you would have the students do very carefully is to put different holes with the skewer into the bone, and then as they feel it, they can tell the difference that the weakening that those holes would cause. So it's another extension activity and a nice way to use the materials further to develop better understanding for the students.
You do have one question going back to clearing the water.
Okay.
Have you ever tried it with motor oil inside the water?
We have not.
One of the extension activities says that you can try it with other solutions, such as things that have clay. You know, maybe it's turbidity that you're clearing up and not a color that you're clearing up, or it could be oil. The oil, it's not a distillation, so it probably won't change. You're not adding heat to make one boil off. So the oil will probably either be trapped or not, more than actually separated. You might be able to get some of the oil out of the mixture if you want to, but it would be a harder thing to show.
Okay. And the last kit that we wanted to talk to you about and to show you about is something we're pretty excited about. And I'm going to let Michelle talk to you about this one.
All right. Okay. I'm going to actually go over here for a moment, I think. So this one is utilizes one of our new products, and we have it in our essentials kit. We also sell it by itself, and what it is are these things called algae beads. Usually photosynthesis and respiration have been used in Elodea is with bromothymol blue is one way that you usually test photosynthesis and respiration. But these are nice because they're little beads. They're made out of algae. Can you switch to this so you can see it better? All right. If you notice, you can see little green beads. I can kind of move it a little bit. You can see it. Do you see it kind of going around? So these are actually beads that are made out of algae. They're made out of Schinidesmus, which is a certain particular algae. And so you can have them count out how many beads to figure out more of a quantitative. You can have them weigh it, but our lab here makes these, produces them, and they make them so that they're uniform in size. What you do with the algae beads before you start is you keep them in the refrigerator, just in plain water. Distilled water is best because there's less, there's not going to be the chlorine and everything that wouldn't be good for the algae. So you put it in the refrigerator, and then the night before you're going to use it, you take it out, let it warm up. You charge it under a light. It can be grow light or it can be an incandescent light. And that kind of charges it and starts the photosynthesis process starting. And you can leave it in the light for a while, or you can put it in the dark, just like any other photosynthesis and respiration experiments. And you can see here that we can measure it at the end colorimetrically. Here's our beautiful colorimetric chart. We have enough in here so that it's 4 times 4 sheets, so you have 16 comparators, we call them. And you take the algae beads, you put them into, can you switch to the other one for a minute again? You switch to these little vials, so they'll measure out usually 3 algae balls into each one, I believe. And you can see them in there. Can you see them wiggling around? So this one has been in the light for about an hour today. And if I take my colorimetric and I hold it up to it, it is clearly at the very end of the spectrum. This is, let me step back a second. So what you put it in is to a pH indicator solution, okay? And then you expose it, and it will change pH based on how much carbon dioxide is there. In, in photosynthesis, it's going to end up using the carbon dioxide and producing oxygen, and respiration is going to be using oxygen and producing carbon dioxide. So depending on what conditions you put it under, you're going to have purple, which means that now you have used up the carbon dioxide. Or if you keep it in the dark, I'm going to take one of them off. It's going to be at the other end, so the pH is going to be lower. And this is doing respiration only because there's been no light to make that photosynthesis occur. Okay, so this is the beginning. This is what it looks like at the beginning. Do you see that? So it's about pH 8.2. Then when it got exposed to light, it was high at 9.2. Or if it wasn't exposed to light, it just did respiration and is at 7.6. So it's a nice way to show photosynthesis and respiration time periods. And you can leave it for, usually takes at least 20 minutes for it to get a good reading to start the process.
And enough materials come in the little glass vials are in the kit, and there are enough for 15 student groups, and the beads can be reused.
The beads can be washed off and put back into water, put in the refrigerator to be used again. And there are enough beads and vials that you can do, each of the 15 groups do 2 vials. So they can already put one in the dark and put one in the light each.
Okay. Any questions on that quick overview?
Can we see the chart and the vials up close?
Sure. I'm going to do it this way. Okay. And I'll put it here.
You gotta go up.
What?
We can't see the vials.
Oh. There we go. How's that? I will hold it with my third hand.
I guess
There we
that's
go. That's you, yes. All right.
You ladies are funny.
And here you can see how it's changed. It's kind of between those two. Okay? And you can see the little balls in there, which are fun. Or beads. We call them both things.
So that's just a quick overview of some of the kits that we have. And the last thing that we wanted to share with you is to let you know that we also have a line of geology essential kits. And these are a really nice collection of our good quality, Ward's quality rocks and minerals. And you can purchase these rocks and mineral specimens as individual specimens, so you can create your own study packs if you want. We sell them in packs of 8 and in packs of 24. And we also have sets pre-arranged, collections pre-done for rocks and minerals, the different types of rocks, and then an introductory mineral collection. So it's a great way to get the rocks and minerals in the hands of your students in a low-cost, effective way.
I think that they're low cost also because they're a little smaller than what they're used to seeing from us, right?
Yes.
Yeah.
And we our essentials line is created as a in-between step. We have our high-end, high-quality
Premium.
specimens that we also have always had, and so our essentials are slightly smaller and but just as equal quality, but just slightly smaller in size. If there's any questions or anything anyone has.
Question on how many of these low-cost kits, like the ones we're showing today, do we have available?
Right now, the essentials hands-on kits, we have 25 of them, and we will have more coming available in the fall. And the rocks and minerals, we have, I think, lots of those.
A lot. There's
There are
like
40,
30 or 40 different collections.
Right.
Yes.
So if you need a copy of this presentation, or if you have any questions after, if you would like to see any of a sample of the instructions that are in the essentials, you can email me or Science Help, and we would be glad to share that. If you need some help identifying standards that these kits can help you to meet, we'd be happy to help you locate those and identify kits that will help that as well. And lastly, we have some of the kits that we presented today. And again, if you have any questions, please feel free to give us an email, and thank you for joining us today.